All right, I think I'm unmuted, yeah? Look, I'm just looking around to see that everything's functioning here. I think we're good. I think we're good. How's everybody doing? There's nobody here yet. You gotta start slow, let people collect. It's a Saturday, so it's not gonna be the most exciting day. I need to look up some of my my sources here, because I found a CEM 3340. What I should have been doing is searching for build. I should have been putting build in the search term instead of tuning. The tuning process is weird on this thing, but more importantly, people post their modular synthesizer builds. And so there's some advice and some component substitutions that I want to give a shot here, because they say if you have trouble tuning it, then do this. It's like, well, that's me. I'm having trouble tuning it. I ate leftovers from dinner, and then my glucose sensor, my Dexcom, went tits up on me. It died. It was the end of this infusion set, and so it stopped functioning at 6 o'clock in the morning. And because of the way my mornings are sort of routined, I wasn't able to change the sensor until just recently. My glucose levels are only just starting to pour in. It takes 2 hours of calibration in order for this thing to, know your internal juices and be able to deliver glucose numbers that can then be acted upon by Android Auto Pancreas system. So I'm just getting these numbers in now, and it's not amazing. It's not amazing. It always happens. You have a gap in your treatment, and it's just during the dawn phenomenon, and then I got to deal with this. Let's see if it recommends any. It's not looking ahead, is it? That data isn't on there. That's weird. It sort of tries to predict what's going to happen with a glucose level in the future, because I get just my little readout here, and then this is what Android APS is doing. Open that up. And then it has a prediction of what my glucose level is going to do next. So I'm going to see. Yeah, it wants to give me insulin, so I'm going to let it do that. Give me those 4 units, buddy. And get this under control. I guess that leftover sandwich is a few more carbs than I'd anticipated, which is what always happens with restaurant food. More fat, more carbs than you think. That's how they do. That's how they do at restaurants. The food's got to be delicious. If you can find that tab that I had open. How do you get to the other tabs? Oh, I don't know if I'm syncing with this computer, which is fine. I'll just do the search again. It's, oops. CM 3340 VCO build. And this right here, synthesizer build part 18. A really good AS3340 VCO design. So this person right about here, I've already zoomed in. Tell you these builds sound so much better than the datasheet VCO. Of course, it's the same waveform, but the range is so much bigger. 0.1 to 50 kilohertz. Tuning this VCO is a breeze. Tuning this VCO is a breeze is not not by my experience. Oh yeah, I got a clear chat. All these little things I got to do. I should put this on a button on the Stream Deck, so I can hit one button and everything will be primed and ready to go. Digisound design isn't even different from the datasheet design except the extra trimmer, the hard sync options, and a few resistor value changes. I think that's very similar to the nonlinear circuits one. It makes all the difference in the world. As far as a synth builder, having been in a modular synth for only 6 months, blah, 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 VCO is a real revelation. It uses VCO as an LFO because it goes down to 0.1 hertz. Here's a new version of the schematic with the op-amp buffer stages drawn in. And this looks fairly familiar to this. looks fairly similar. There's a couple differences though. Let's see what they are. I guess I don't have like a comparison view here. Might be some of the values here for the for this sweeping piece right there. This is DJ Everyday, who's one of the tech DJs, and it's a mix from 7 years ago. 7 years! But DJ Everyday is pretty awesome. He plays good tunes. And he's never gotten me a copyright strike. Oh, these are fairly popular, what the heck, huh? What do you call it? House, minimal, tech house, there we go. Hard sync and negative hard sync. I mean, there is sync in here, but I don't think it goes, it has rise and fall, I see. So instead of rise and fall, this one has negative and positive sync. And they're assuming 15 volts. However, for use with the dual 12-volt power supply, R23 needs to be this. In the case of tuning difficulties, change R4 to 270. So those are, I'm gonna have to find them. R4 going into the multi-trim pot. 200K, they say to use 270. So yeah, we're gonna take a look at that, and we're gonna replace some of these things. What are they using here? This one, 100K and a 2M. Oh, well, this one uses a 1M. I could explain why I'm having a little difficulty here. 1, 7. Yeah, I spent 10 years doing exactly what we're doing right now. What I'm doing right now, which is looking back and forth between schematics that are drawn completely differently but do the same thing. Because if you ask two people to draw a schematic, you get the differences as strong as this. But yeah, it's there's a lot to interpret here. A lot of it is math, but then I feel like in my education as an engineer, I didn't get enough like of the interpretation kind of stuff, like the, oh, you didn't know to do X, Y, Z? It's like, no, I didn't, because nobody really explicitly said it. All the courses were just like soulless math classes. I can't quite see the end product from looking at it. I see function in schematics. I see function. Because the end product is a completely rearrangement of what's in that schematic. You can arrange things in a particular way, and you'll try to put, you know, circuit junctions together, or have things be in a functional location as opposed to being electrically exactly what's there. I mean, it's supposed to be electrically exactly what's there, but it's just things might be further apart or closer together. It's not exactly, you know, there's that divide between schematic and circuit board. But yeah, there's a lot of creativity, art, and decisions in making something like that. It's not as cut and dry as everybody says. And the funny thing is, like, how do you route a trace? How do you route a trace? Do you go directly at a 90 degree, or do you sort of put a 45-degree angle in there? And apparently that's just down to preference. It's down to what you think looks good. Because the old adage that a 90-degree angle would be an acid trap, as in a place that acid would pool and end up over-etching, is wrong. So why don't you just use 90-degree angles? Well, because it creates blah, blah, blah RF. Well, in digital electronics, you're not even getting close to RF levels of signals online. So it's actually not that big of a thing. It's sort of an overreaction of engineers, and then you also do it to make it look pretty. Even though this stuff, I don't know, I think it looks tacky when you start using circuit boards as decorations, but you know, some people like it. But yeah, like this thing was made so long ago that some of those techniques might hold water. It looks like they're using solder through for the vias. This is an old like 1970s design. This is a speak and spell. Well, there's some 8s in there, so maybe it's a 1980s design. I don't know if the VFD still works, but anyway, yeah, in modern circuit board production, stuff like an acid trap is just that's not a thing anymore. Trace lengths matter. Yeah, well, with if you think of all your traces as having resistance, and that resistance will fight a change in current, I guess you can think about it that way. The more wire you have, if you have a bunch of lines that are different lengths because they had to do sweeping turns, then your signal is going to come up to the right voltage level at a different time than the other one because of the change in resistance. So you meander your traces. You have them do little squigglies, and that way everybody is communicating in lockstep. And you don't need to do anything on the other end in order to compensate for that. You get to really high speeds. When you get up to RF speeds, you start having problems where there's a different voltage on your line. It's like an antenna that's transmitting from point to point. So you'll have a different voltage on one side than the other, and it needs time to propagate. Crazy stuff. And then you can throw into the mix that all of these things, you don't even consider them being electrons moving around. The electrons happen to be moving around, but that's because the charges on the outsides of the metal are encouraging the electrons to move. It's weird. You get pretty deep down into the physics sometimes. Power on. Oh, that means measuring millivolts. Yeah, we're gonna go back to that, but first we need to make a couple substitutions. God, I hope my glucose level can go down soon. I took the puppy on a morning walk. She should be pretty good for the rest of the afternoon until people get home, but I don't know. If she comes down here and asks for a walk, I gotta take her on one. I guess, how do they work? I mean, polar spins of subatomic, whatever. You don't need to know too much about magnets. You do. I mean, you would, inevitably, studying this stuff, but... We're gonna have to locate a bunch of different parts to replace. There's some substitutions here that are specifically pointed out, having to be made on the 12-volt version of the circuit. Oh my God. Sync, soft sync, other sync, mod. Yeah. We got work to do today. Let's see if I can get to the bottom of this VCO and actually get it working. What are these diodes doing here anyway? On the positive end, coming from the output, the triangle. Oh, we're turning the triangle into, not into a pulse. Oh, we're turning it into a sine wave, but we're using, oh, that's kind of weird. We take a triangle wave and we apply the diodes and the diodes in parallel with a 40 and a 1 nanofarad capacitor. How'd the racing wheel turn out? Good. I mean, we got caught at the end of that build because I ran out of buttons. Like, I couldn't represent buttons in the software without, because there's only so many physical buttons in that system, and we didn't know the API, so we didn't know how to tell the chip that we're hitting additional buttons. There's probably a way to do that. If I downgrade the software to the open source wheel control, which the wheel is just sitting. Oh, did I move it? Oh no, it fell over. Okay, why did it fall over and what did it break? Oh, jeez. I must have bumped into it. Hold on a sec. That would have been an incredible crashing noise. Oh, it fell into a mouse pad. Perfect. Fell into a nice soft mouse pad. Must have been an incredible thump. There we go. So there's the wheel. So anyway, there was no way to send additional button presses, but I had lots of buttons to press. That thing is full of buttons. That's why I bought it. So I had to buy, and I had to actually buy 2 of these. Twisted Sister was kind enough to donate enough money that I could just buy a second one, but I had to buy the wireless wheel system that they use, that Granite Devices has. And you can buy just the circuit board, but not through Granite Devices. You gotta buy it through a third-party seller. So I bought one of these wheel things, and we did a full top-to-bottom reverse engineering. God damn it. A full top-to-bottom reverse engineering of the thing. Happy belated birthday. Thank you. Appreciate it. Walrus. We did a full top-to-bottom reverse engineer of the digital signals that were involved with the steering wheel. And it uses Bluetooth Low Energy, which is well documented. We were able to make an entire, like, just a whole segment of the program, of the microcontroller that I use to communicate with the LIN bus. It's now also faking being a Bluetooth Low Energy 2-point system where it just connects to the wireless wheel, and then it'll hit buttons as the wireless wheel. So it has to fake being a wireless wheel module. And I couldn't, I mean, I guess I could probably have put the wireless wheel module in the steering wheel with everything else, but the steering wheel buttons are on a weird kind of like 3-tong matrix kind of deal. So they're sort of weirdly, they're weirdly pulled. So we stuck with the LIN bus, and while it's interpreting the LIN bus, it's also faking being a Bluetooth module to the actual wheel controller. Publish your API, like, please. I would love to know how to communicate with that stupid thing. But yeah, I don't know how to communicate with it, so we had to put on a trench coat and one of those fake glasses with the nose on it, the nose and eyebrow glasses, Groucho Marx glasses. Which is mad. It was a mad piece of Twitch engineering. It was like one of the crazier things that I've done is on the fly dedicate a couple streams and get an entire new facet of that wheel functioning. And it works. The only problem is, at least for my summer car can only take so many input numbers until it doesn't take any more. And so the input numbers on the wireless wheel were off by like a bunch of buttons. I don't know why it is that way. I don't know why the Granite Devices thing does it that way. It's got like 128 buttons, and it's got a bank of the initial buttons, and then it skips a bunch of numbers, and then the wireless wheel gets the rest. It really feels to me like there is some way for me to communicate directly with the chip to tell it that I'm hitting buttons. It would be a much more elegant way to do that, but Granite Devices does not have documentation as that. And there are like on the internet, there are rumors that they'll release the API so that people can use it. There was somebody who jumped into chat and claimed to be from Granite Devices, and they were like, yeah, we're gonna release the API soon. That was like 6 years ago. Like, it was like 4 years ago. But still, it was like ridiculous. Like, I'm not just gonna sit here and wait. So I reverse engineered their shit. I think I put that on GitHub. I'm not sure. I need to check up with GitHub and do a bunch of uploads of stuff that we've worked on. And I probably should cut up our old streams and make those into edited videos for the main channel, because the main channel has cobwebs all over it. It's disgusting. I need to get a broom out and post some updated videos to it. And I can do them, you know, that Rabaz video, his networking video that he just did, that's pretty inspiring. I need to do it in that style. I think I need to. The problem is, I'm a perfectionist. I'm gonna write down the entire voiceover and then do all the stuff. Yeah, he did like a what he's done to his network setup video. I know it's weird. Did you know Robert made videos? Creepy. Unironically learning how to be a network engineer. I don't know if that's, he's not going into that. He's still working on the home lab. His is more of like a file server storage lab. It's not really so much a home lab. It'd be neat to have a home lab. I don't really know anything about networking stuff. The networking stuff here is so old. So old. We've got like 6 or 7 year old Verizon stuff. It's all so slow. circuit board layout I made for this schematic further down the article is verified, and the placing of the buffer stages follows the numbering on the schematic drawing. The octaves control, I used to recommend use a 100 kilo ohm potentiometer with a center detent, but I think after due consideration that it's better overall to use a normal linear potentiometer. I thought it would be useful to easily retune the VCO after you've been using the octaves control knob, but those potentiometers often are not linear. Often they are logarithmic towards the center point. Decide for yourself what you want, whether you choose to use a normal 100 kilo ohm potentiometer for the frequency fine control, not one with a center to blah, 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 blah. I put 47K resistor for R21, which is the pull down resistor for the square wave output. It originally was 10K. The Digisound 80 circuit, the CM3340 was used, and that we will find too, use 10K if you're using CEM. It's stated in the datasheet for the AS3340 that it needs to be 51K, but in practice it doesn't matter at all. Okay, so I use 47K. For the current limiting resistor, I put a 1K. R23. Oh God, it's so small. Current limiting resistor. R17. R23. R22, 21. I think he's talking about the other side of his, what the heck is that thing? PWM control. R23. I don't see. I don't see it. R21, R22. It should be around here. There it is. Oh, it's on negative 15, 910 ohms. To connect to negative 15, it says use the 910 in the schematics, but I always play it safe, use the 1K. Huh. Mica type for C7. Yeah, we're not using a high quality for C7. This is a frequency determining capacitor and must be stable with temperature changes. So do not use ceramic capacitor for C7. When soldering in polystyrene, make sure you don't heat it up too much. Yeah, they hate them. Cool down value will stay changed. Don't worry, with normal soldering, they'll be fine. Never had a problem with them myself. Some polystyrene capacitors have a black line on one side that indicates which one is on the outer layer. This leg should be connected to the lowest voltage potential, usually ground. There's a lot of stuff that I did not know. I don't think I have anything that has a polystyrene. Today I was watching bad movies and eating mozzarella sticks 12 years ago. Thanks, Facebook. I haven't seen Facebook in years, and I don't plan on seeing it. I do not plan on looking at Facebook again. I have graveyarded my account instead of deleting it, because I don't even want to give them that data point. But I think that's where all my birthday well wishes came from. I had people like out of the woodwork, like I haven't talked to in many, many years. Yeah, that's the thing, is like if I want to contact like distant family and stuff, it's probably the only place I can do it. At least I think it'll email me if I get a message there. I think if somebody sends a private message to me, I don't know though. This is what we're doing. Use a 680 ohm for. So this is the stuff that I think we need to do. Oh, nice, and he made a nice little list for us to look at. So we need to figure out where on their circuit, which isn't the same as our circuit, it's a little bit different. We need to figure out what the components are there, and we need to swap them into the main one. I actually did a research while we were between streams. Actually, I did the research on the toilet. Smartphones are great. We don't get bored anymore. Stop leaving messages. How do I get rid of this chat? I can't. They took that away from us. I can't disable YouTube chat. I don't want it. I just want, it's my dumping ground for the VODs, because they'll stay around longer than a month. Yeah, reading the shampoo or the mouthwash bottle. I used to do that. There was one time we had a bottle where all of the letters started coming off of it, and they wouldn't just like flake off and become little chips of stuff. Like an entire letter would come off of the bottle. It was great. Facebook around to promote unionization and anti-corporate propaganda. Well, that's righteous. That's very righteous. We were brainwashed when I got out of college about how horrible unions were. They brainwashed us good. Boo-ba-doo-boo. This sound, the little woo that's going on there, that's in a 505, which is a sequencer. They just have that sound effect in there. They tried to get me. Well, you know, this was before everything went tits up. Forgot math. What are math? Brother was fully indoctrinated by the U.S. Marine Corps. Damn. They're kind of professionals at that, huh? All right. I kind of want to get to work. It's like 30-minute intro. It feels weak. I can do better than 30-minute intro. I can keep talking crap for longer. Nah. All right, yeah, let's just get started. DJ Everyday is who we're listening to today. Those are good tunes. I need to find the window with all that stuff. The window with the tunes. There it is. I'm just gonna fade this out. Oh God, there's a pop-up in front of it. Remember when the internet was completely unusable due to pop-ups? Then we got pop-up blockers. Now they want us to just watch ads. They don't really pop up anymore, but they're just completely intrusive still. We've learned nothing, and we're backsliding into all of the things that we got over in the early 2000s. Okay, let's see. Hi, welcome to Saturday. I'm not answering your question because I'm actually working right now. No. Okay, anyway, welcome to Oh Bother. Anybody who's not familiar, if you're finding me through YouTube, yeah, this is my shop. It's where I work on stuff. I've been on kind of a synthesizer kick lately. Basically put upon by a friend of mine, Julian, who does music, Zelikovic. Here's a link. There we go. Linktree/Zelikovic. I can never remember how to spell even the most basic of words. This one is a challenge, but there it is. So check him out. He has been on me for about 20 years in order to build a synthesizer. And this is the best that I can do to get into synthesizers and learn them, is to get into modular synthesizers. So apparently you could just buy the circuit boards for modular synths. You can just go out and you just buy them. And they give you these circuit boards and you go, wow, what is this? And they go, I don't know, good luck, bye. And basically you're on your own to figure out how to build up that circuit board. You're lucky if there's a tutorial, or sometimes you get people's build logs, or sometimes you get the person who created it themselves giving you a bill of materials and what to buy and what to put in. You can buy these things as more comprehensive kits, but they're more expensive. They're more expensive, which is why it's even more expensive than that to build them from scratch, because you're buying all of the components individually and you always buy a little bit extra from what you need. Then you end up spending more than what the kit costs. Oh well. I've blown up a fair number of microcontrollers in my day to justify the extra parts, and now my shop is fully spooled up to do analog stuff as well as digital. But what we're learning lately is that analog is a complete pain in the butt. It sucks. The reason for that is that it's analog. Everything needs tuning. Everything needs to be tuned within an inch of its life. Generally, with electronics, it's so much less frustrating to work on digital stuff, like, hey, make a digital clock. And you go in there and you program the digital clock and you solder some stuff together. And as long as the connections are made, it works, right? That's the point that I was at with digital electronics. I can build stuff and it just works. We were talking about the steering wheel project before stream. And we had to do a lot of reverse engineering of digital protocols in order to like hack into the steering wheel, the digital electronics in the steering wheel, and then also get a Bluetooth fake being a Bluetooth low energy receiver that had connected to a transmitter. We had to do all that stuff, and I was in my element. Our brains were sparkling. We put together all that code, and it worked. It worked perfectly. There's a little tiny bit of delay on the buttons, but it's not that much. So anyway, like, that's digital electronics. I go over here to analog electronics, and they're like, this circuit is a transistor and an operational amplifier. And I try to solder all that stuff together, and it doesn't work. It just doesn't work. I feel like my the skull speaker broke me. There's like the easiest amplifier circuit that you could possibly build. And I put it together, and a little unorthodox. I put it together through plastic. But all the connections are still there. We double checked everything, and all it did was produce lots of heat. So I have a couple pre-made amplifier boards coming in the mail, and then we can fool around with those and see what happens. But in the meantime, we're back to the annoying part of analog electronics, the tuning. Our voltage for this oscillator is slightly less because we're putting it in a Euro rack. It's not just a modular synthesizer also includes a Euro rack. We're doing Euro rack, which means we're doing modular synthesizer, but there are other modular synthesizers out there, and some of them use plus minus 15 volts, which is what this chip was originally made for. This chip was originally made for in the 1980s. The creator of the chip died and did not distribute them any longer, and they became rare until the fellow's estate, his wife, allowed the creation of the chip again. So now we were able to get this nice vintage sounding, basically it's a voltage controlled oscillator chip. And it allows for the things that modular synthesizers require, like having 1 volt per octave signal, having control signals come in, having a sync so that your waves are all doing the same thing. Pretty cool stuff. So anyway, I did a little research on the toilet, and I found out that I'm searching the wrong stuff. Instead of searching for tuning methods for the 3340 for the chip, and again, because I just bought circuit boards, nobody tells you exactly what goes on after building this. So I only had nonlinear circuits doesn't do like extensive tutorials on how to get this thing working just right. They say, here are the components, here's where they go, here's a couple little modifications. Here's the schematic that barely is complete, and then you're off on your own. So I had to look up how to tune this thing. None of them are talking about how to tune nonlinear circuits version of the 3340 build. They're all very similar because there's only so many ways to hook this chip up, but they're all just a little different in their own little eclectic ways. So we've had to look up other people's tuning methods, and then we don't necessarily have all the abilities that they have to tune it. We're missing a potentiometer. What is that? How does that work? We're all principally doing the same thing, though, so it is possible for us to get this thing up and running. Our voltage is less. I found out that the better way to search for information on how to tune these things is to search CEM3340 build, because people do build logs. And so I found a build log while producing my own logs. Okay, what do I mean by tune? The 1 volt per octave standard on a Euro rack or modular synthesizer means that I think it's the note C4 needs to be 0 volts going into the control voltage. And so you need to get that right. You need to make sure that your span of notes are linear, so the frequencies that you're giving this thing are standardized. You need to make sure that your sine wave looks like a sine wave. You need to make sure the amplitude of the sine wave is correct. It's just, everything needs to be manually tuned into this thing. And then, of course, because I'm using a different capacitor, the temperature range could also affect it. Hey, Milk. I don't think I have a poly capacitor. I don't think I have anything like that. I need a 1 nanofarad poly something or other capacitor. I wonder if I should look that up. We should probably look that up. Which means I won't be able to tune it completely today, but let's see if we can find this. Let's get the voltage out of there. I can't use the arrow keys in your little... Why are they messing with the search bar? This frickin' company. Oh my God. Look at all these polyesters. I hate how it's cheaper to get a kit. And this one just lies to you. I said 1 NF and it says, oh, here's 0.1 UF. No, we're looking for 0.001. Metallized mylar. 102 on one of those little baubles. Wait, I think I know where I have some of those. They've changed their search bar, so like when you click on it, it highlights the whole thing. And it's like I'm already typing something by the time it's bad. I don't know what they've done to it. I mean, the search function is all I've got. It used to be, Amazon used to be so powerful because you could go to it and you could look at what people are buying. And they decided, wait a minute, that discourages you from buying from like Joe Shady's company, who just made this listing on a white label product. So we're going to completely hamstring the search function. And that was when Amazon became nigh on nearly useless. All right, so I think I've got a board that has a couple of those. I wonder if any of these are high quality 1 NFs. Oh, there's dog hair and dust on everything. Dog hair und dust. I mean, some of these are poly, but they're not. I don't know what the codes are. Hold on. If any of these are 1 NF, these yellow ones, maybe we could use them, but I think they're multi-farad. And then I saw one of those little baubles with 102 written on it somewhere around here. I think these don't have 102 written on them. We could look at those though. That's a power supply though, because I don't think the power supplies really use precision components. Not on this level anyway. Those are 0.1 UF, and they're not quite what I'm looking for. That one I've already removed all the capacitors from, except for the one big one. Let's see. I think I might have the part. That's why I'm looking at the old circuit boards over here. I could have sworn that I had this part already. This says 102, but it says 2 kV on it, and I don't think it's a capacitor. It is a capacitor. Actually, that might be exactly what we need. All right. I don't know what kind of cap that is, but those are different. Those aren't capacitors. This is an audio board. That might have the value we're looking for. It's an old sound card. And this, I think these are 0.1s. If these were 1 NF, I would be able to use them. They auto add the ghosted suggestion, additional words, unless I hit an extra key to tell it no. Yeah, it's gotten bad, hasn't it? They keep trying to steer you towards buying really crappy products. This one was a light bulb. And it's like, I'm not here to buy, I know exactly how to search what I want. I wonder if Jeff Bezos has to use the shitty search, or if he has like his own special search function. What do you think? He probably has like a special Actually, he probably doesn't do crap. He just tells people to do things for him. I'm gonna end up like Michael Jackson and hire a whole crew of people to act like normal people at a grocery store. Alright, let's see if we can find a metallized polyester, polyurethane, whatever, in this collection of electronics. Does he just own everything on the platform? Is there something on Amazon that he can't afford? Well, he can't afford to look poor, so I guess, you know, fingerless wool gloves. You can't afford a good search function. Yada la da 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 da. Yeah, these kinds of like multi-layer monolithic ceramic capacitor, I feel like I've seen these around. If not, is there a surface mount? Let's see. SMD poly cap. I just want images so that I know what I'm looking for. That doesn't really look like poly. Usually it's, yeah, these guys. That's polymer. And they want polyester multi-layer, which is, I've soldered some of those before, and they're very, very sensitive because they're full of plastic. Polymer counter electrode for space. So are we looking for, we're looking for one of those yellow caps. And we're probably looking for it to say 102 on it to be a nanofarad. This is my search function. Look, I saw a thing. This says 102, but it says 2 kilovolts. I don't know if that's going to be a 1 nanofarad. And I don't think it's polyester. I don't know what, it's some weird giant ceramic protection cap. I don't know if that's the one for us. Now, some of these have these codes on them. S14. What is the... So let's look up SMD capacitor code. Well, actually, let's look for one of the yellow Jiminy Johns. One of the yellow ones. I think this board has more of a chance of having a small one. We haven't done anything to this board yet. This is a external sound card that does 7.1. Let me brighten this up a little bit. It's creative. So there's the audio codec chip is Cirrus Logic. So there's a ton of capacitors on here. I think we'll be able to find what we're looking for. Miniature M&Ms. They're much smaller. What does that even say on it? All right, hold on. I can't read. I've got to get closer. $104. We're looking for 102. 106. This is the least legible. 106. 106. Those are big capacitors. Are they all going to be 106s? It looks like they settled on a cap that they really liked and decided to put a couple of them in here. 226. 106. Now, 106C, I'm guessing is 1 microfarad. Is that? No. Because we're looking for 102, and that's a nano. 3, 4, 5, 6. It's like 100 microfarads. Let's just check. Actually, that's going to be in here. It's 10,000 farad or nanofarad. Okay, so it's going to be 1 is 1,000, so it's 10 microfarads. Man, farad is such a weird unit. It's so annoying to deal with. Since we're on analog stuff, we got to deal with farads all the time. 226, which actually might be a good value for that component. Well, actually, when we do the mods, oh man, so many 1117s on this board. Is there a larger one? No, I'm in search of a larger 1117 because of the crimes module needs it. But anyway, I want this capacitor to be the normal value because there's a couple mods that we're going to do in order to bring this into a 12-volt circuit. And stuff that we didn't know about that I should have known. These are all 106. What the heck? All right, so something on the order of magnitude that I'm looking for will be approximately this size. That little guy right there, C166. That is a 105. So it is a 1 microfarad. We are looking for a 1 nanofarad. We are looking for a 102, which apparently is harder to find than I gave credit for. But yeah, okay, so I know approximately the size that I'm looking for, so we can keep our eyes out for a little thin boy like that. There's 2 here. I think they're both... I think they are both Creative Technology Limited, 2007. 226. And this one's probably 226 again. Where is that? 105. Okay. 105 and 226, huh? That's a shame. Okay, so let's see if we can find one that says 102 on it. This is a little larger. We should probably back up a little bit. 685, 6.8, 33, something or other. That's going to be a 104, isn't it? We need 102 in yellow. 2.2. And then I don't know if that's 2.2 pico or 2.2 farad. Probably farad. Farad. Let's see. I can't get low enough to see this one. That's another 2.2. Where are all of my 1 nanofarads at? What happened to them? 104. Jerks. Bunch of jerks. What are you, C10? Is that a 2.7? What is that? 270. We need 102. I'm starting to hate capacitors. Starting to just straight up hate them. 685. Three, 6. I can't read this one. I think it's 6N5. Okay. None of these are right. What are you guys? I have hatred in my heart for the charge storage elements of capaciting. 104. Ah, need 102. These are probably the type that I should be looking for too. These bundly dudes. Okay, so that didn't work. One enough. I remember looking at these. I don't think any of these were 102. All right, let's check this big boy. See if we got any on here. Big circuit. This is for the tuning capacitor, so it needs to be a high quality cap instead of the ceramic one that we used. The ceramic one that we used is nice, but it's not as stable and good. What the heck are these things? There's a lot of components on here that I don't know what they are. These are unique. I wonder if they're coils or something. Why are they green? Talking about, where's my pin tool? Hold on. Oh, there we are. Talking about these two. Man, we are really close right now. We are close talking. I wonder if Y means that it's a, well, actually, I think Y is crystal in this case. Why would be X and Y? No, this is a, this thing is a high speed, I don't know if, well, I guess it's high speed. It's a recorder, like a professional recorder. And the other Lone Star sent it in because his job used to involve a lot of, well, it still does involve, his old job involved AV stuff in New York City. And yeah, what happened was these video recorders, the SSD recorders, sat in a rack, and their little tiny fans were doing the absolute best they could to cool everything down, except this one's fan died. and so it basically ate the processor with heat. And I can't position this to where the electronics are. There we go. So he sent this in to see if I could do anything to it, and if not, sacrifice it to a worthy cause. And so we are at the sacrifice it to a worthy cause portion of this teardown, which is the longer part of the teardown, and it'll take some time until I find a good home for all the op amps and stuff that this thing has. But it's got some cool stuff. Got some cool stuff in it. Dad Dietz, there's a name I haven't heard in a while. How you doing, Dietz? Thank you for subbing with Prime. 62 months. We don't want no water. Let the mother laser burn. Hey, those guys are from Philly. I met their keyboardist, worked with him a little bit on that Theater Globe after Bloodhound Gang became Wolfpack. And then they did, I don't know, they've been evolving since then. What is the value? 606, I think I see on it. So that's not even close to what I'm looking for. I think maybe the size of the, whoa, what was Q2? That's neat. The size of the capacitor when we get down to 1 nanofarad doesn't necessarily have markings on it, but I'm trying to find a special one. I'm trying to find a special capacitor so that we have temperature stability on this thing. We're at the stage of tuning the VCO where I need to do stuff correctly, which is a major pain in the butt. But I need to do stuff correctly to make sure that something I did didn't make it stupid. And it's very likely that something that I did made it stupid. So, so I need to kind of backtrack here and look for the correct parts, or order the correct part. I don't think I'm going to find any precision caps on that. Let's see if we can find a 102 somewhere else. I could have sworn that these boards had those in there. But they just have similar looking caps. This thing is kind of cheaply made, but it might have a decent one. Yeah, I think when even the special poly caps get down in value low enough, they'll end up looking the same as all the other components. Although we looked up poly, and I guess it's not layered polyester. I think that's like a Sony thing, but the poly caps that we did look up are the yellow and black ones that have sort of the casing around them. Well, these say they're poly, but I don't know about that. I think they're just in an open relationship. So I guess we're looking for these types as well, and those can have weird markings on them. The ones that are on the modem board, which I don't have in front of me, there it is. The ones that are on the modem board have S14 written on them. So let's try, oops, try capacitor marking S14. Boom, boom, boom. SMD code search. That's not what we're looking for, but maybe it'll have 323, blah, blah, blah. That's not working at all. That's a video? Why is everything a video now? Here we go, the DigiKey one. Does not even have S. Seven, eight, nine. 1, 2, 3, 4, 5, 6, 7, 8, 9. R. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, here we go. Q. What? Very clearly, what I'm looking for is S14. Why do you not show me S14? That ends at Q. Actually, it goes to A over there. Is there an S on here? It's just not in alphabetical order? No, there's not. 3-digit, 079. 4-digit, 1089. No, there's an R, and then the last digit is S. EIA19 BPQNM. Ah, what the heck? 2 characters, 1 number, and 1 letter, in which the letter represents the value and the number represents the multiplier. It's like, I can't. There's no other interpretation. It's an open 4. SI4? Either way, I don't have the ability to look it up on their system over here. S14 capacitor. Oh, now we're just making stuff up. Radial leaded. No, that's not the right thing. SMD. See, there is a diode marking for S14, but well, actually, is this labeled? It's labeled D4. Okay, never mind. That's a diode. I told you all along that it was a diode, chat, and you guys didn't believe me that S14 was actually a diode mark. You guys are so dumb. You guys are so dumb. It's so hard to be around you guys because you're so dumb. These are like high voltage poly, and they're also 104, so that's 0.10. That's a metal oxide varistor. And I don't think there are precision caps on this one. What's on the other side? Man, we are really close right now. This is a little unnerving. I guess that's a 4520A4. I want to figure out what that is. I know it's not a 3-volt regulator. It would be nice if it was. Transistor, NPN. Yeah, 420 volts. Jeez, 2 amps. Those are diodes. Mark D3 and D4. The capacitors in here are ceramics. We are looking for more hoity-toity, high-quality, high-class caps, and we're not finding them. Not finding them anywhere. I found stuff that was close. Like the ones on here are very close to what we need. But 1 nanofarad, or technically we would need like a 1.5. If I found 1.52, that would seal it for me. That would be exactly the part that we need due to the difference in voltages. But then again, I think we can tune around that. So if it's just a 102, which it does say that this cap is a 102, but I don't know how temperature stable this is. I don't know what this is. 102, 25 kV. Other window. Oh my god, I've got too many windows. 102, 25 kV, blue capacitor. High voltage ceramic chip capacitor. I don't. That's the same. It's you know that's not what we're looking for. We're looking for a poly cap. So it looks like I gotta order something. It only takes 2.5 hours for me to figure out whether or not I need to order something, huh? Monolithic ceramic mylar film capacitor. Oh, those things, huh? Do I have any of those? 630 volts. These are more for like power supply safety and stuff. This is a big assortment kit for 25 bucks. Means I'll never not have a ceramic capacitor. But yeah, that does have 1 nano. Polyester box. Now wait, do they say polyester or do they mean that it has to be a multi-layer film cap? Where's our tutorial? What? Change the timing capacitor C7 from 1 nanofarad to 500 pico. 470 pico will work too. Not always necessary. See text. Oh my god. Polystyrene is what they say. frequency determining capacitor and must be stable with temperature changes. So do not use a ceramic capacitor for C7. When soldering in a polystyrene capacitor, make sure you don't heat it up too much. That's typical. So I need to find a polystyrene. What are the ones we found? Polyester. Metallized polyester. Polystyrene or polyester. Okay. Or silver mica type. Then down here, there's tests. Where's the other thing about? Pulse width, temperature compensation. Don't place this VCO directly over the power supply in your modular setup. If it gets influenced by the heat, the voltage regulators, by the voltage regulators too much, it can detune. True of almost all VCOs. The AS3340 has internal temperature compensation, but this only really works for changes in room temperature. Well, he has further notes on the cap. Be a normal trim pot, not a multi-turn. The influence is minimal. Let's see. R7 for more range. We've got nothing but range from the polystyrenes are very sensitive to heat. But he said polyester polystyrene. He said it was okay. He's lying to me. Actually, Pseudo, your track record in being correct is under question as well. Okay. So I guess I'm probably okay to buy, but half a nanofarad might be called for. 1 NF to 500 PF. We found that putting a larger value in there kind of limited our current selection. There's something is wrong with the current selection, because our range of values goes from like insanely small to just outside of where the thing stops being able to transmit the wave. Oh, you're talking about yeah. Soldering heat. Yeah, no, you're correct in that. Yes, you damage the layers of sensitive plastic, and so the capacitance changes as you apply too much heat. When we're talking about heat sensitivity here, we mean what they're talking about, where you put it into the Euro rack and the power supply heat gets to it and changes the frequencies around. Otherwise, you might only get very low frequencies out of the VCO. Feedback from many readers who built the VCO for the Eurorack. Again, this change is also not always necessary, but I leave it up to you. Many people commented that they needed to do this change to get it working right on 12 volts. Instead of 500 puff, maybe hard to find, you can also find 470 puff capacitor, as long as it's not a ceramic one. So it's like the stipulation is like, just don't put a ceramic in here. This thing starts at 1 NF. 1 NF to 1 UF. Do I have anything that has box capacitors? I don't think I do. I didn't buy a kit of these. I just bought single values when I bought it. So I have a bunch of the high quality polyester capacitors, but they're 0.1 UF. They're not quite right. So yeah, I gotta get something. Monday, tomorrow. These all start at 1 NF. I can't go below. I can do 0.1 UF because I happen to have some, but that's too low. If I put 5 of these in parallel, I don't think I'd have any room on the circuit board anymore. All right, so what's the call here? I think I just get this kit. I think I just buy this kit. Like, this one has more caps in it. I don't know how often I really need these things though. But all right, let's we'll get that. For now, this thing is not in the Euro rack, so it's not really subject to the heating and stuff that the. So we'll continue with the 1NF ceramic that's in there, and we'll you know, keep this in mind when this arrives. What's going on? Something's not happening here. Okay, Amazon just completely froze up there. That was cool. Check my orders to see. Okay. So I've got a bunch of the stereo stuff, the speaker stuff coming in the mail today. All right. There. Place the order. You guys are going to get all of my information off of the reflection from my glasses, aren't you? All right, so there's that. So that's the correct capacitor on the way, as recommended by this person who's apparently learned a whole lot. I wish I had time to read and like digest all the stuff that's on here, because this is all really good information. This is Eddie Bergman, and this is from article from 2020, January of 2020. Synthesizer build part 18, really good. Okay, so let's check the changes. And what we need to do is cross compare the changes from one to the other. One schematic to the other schematic. This is like some advanced stuff. Because we have, watch, now that I've ordered that kit, I'm gonna find the part on one of these circuit boards. It'll just be right there. I think the IBM one is too old. I don't think I should be using any capacitors from it. I wonder if any of these are 102s. Yeah, it's too old. This is too old. The capacitors are probably not that functional anymore. They actually might be perfectly fine. I would actually feel bad taking parts from this thing. That's my home defense weapon, that circuit board. Okay. Oh yeah, we're still in the computer. We're stuck here forever. We have two circuits. We have this one and we have this one. And these are the same ASIC is doing the same thing in both of these circuits, right? The same ASIC is doing the same thing, and everything is based on the data sheet from it. Solid tantalum? I don't think so. They look like the bobble ones, the little like bubble. They're a little bigger than your normal like flat ceramics. Maybe those are. Is that what a hold on. Yeah, you're right. They might be tantalum capacitors. Well, it would be nice if I could find them in the right value, but none of them have the right value. So we've got tantalums that are all across the different boards here, and none of them are the right value. Just annoying. Probably the best source is this old joystick one. And this one had some similar values, but I think they were all like way above 1 nano. So whatever, I got the ceramic ones coming in the mail. So the first modification that we need to make sure is correct is change R23 to 680 ohms. So we have R23, R24, R26, R22. There it is. R23 is coming directly out of the 15 volts and going into pin 3. What did nonlinear circuits do? Just connected it to power. But I don't know if that's pin 3 or not. Oh, here we go. Why is that negative V minus? Huh. But this one is a 620 ohms, so that's R1. So that's already been done into pin 3. The non-numbering of the pins really gets me on that circuit. Oh, negative voltage, yeah. Okay, so 910, and they say to put in a 680, and we have a 620 here, so we're good on that mod. Change the timing capacitor C7 from 1N to 500p. We put ours up to 1200p or something like that, right? We went up to 1200 and it limited our frequencies into a functional spread. Right now, as it is, we can turn the frequency up so high that either the drive circuitry or the op amps can't support it anymore, and it goes down to no amplitude. 470 will work too. Change resistor R4 for 270 or 300. R4. R4. Saying my R's in a weird way. R3. R14. R4. 200 kilo ohm. So it's 1M and 200K and then the trim pot. And they say to change it to, I don't know, this doesn't feel like they're 270 to 300. So we have the trim pot up here, and this got a 150. But the trim pot's at 20K. What do they have on their circuit? 100K. 20 and 150, so that's 300 kilo ohms total, and this one's got 170 kilo ohms total, which I don't know if that's wait, trim pot multi-turn. Oh, that's down here. No, it's not. Wait, what? Huh? 100K trim pot to ground. That's this one over here. Trim pot C linearity, that's a 10K to ground. It just makes it more or less sensitive. But the multi-turn is over here going to positive voltage. And this isn't the multi-turn. That one is. Maybe I mixed those up. It goes to 150 kilo ohm resistor. Let me look at the PCB. Oh wait, this PCB is different. The modifications are. Maybe I mixed up the trim pots. That would make sense for why it was so difficult to work with. Let us see. So we are on pin 3, which goes to a 620. Oh no, we already looked at that one. We already looked at pin 3. We are on pin, oh God, where are we? Pin 15, which goes a whole bunch of different places. So that's this one right here. 15, and we're looking for the 10 kilo ohm trim pot. That's the multi-turn. There is a 100 kilo ohm trim pot, and that's 20K. This one's 100K. They have a multi-turn in here. This one is just a dinky little 100 kilo ohm, and that goes to, well, it should go to a 200 kilo ohm, but it goes to the 2M2. 2M2, that's R10 equivalent on the other circuit. Sorry, I'm very, very much into this, and I'm in my own head right now. So you guys have to tolerate the machinations of a weirdo. We're going over in this direction to pin this one. 9, 10, pin 10. Why are we going to pin 10? What? Maybe I got the pin wrong. Hold on. Yeah, the difference between these two circuits is it's weird, right? I'm gonna remind myself of what I'm doing. Resistor R4, 270 to 300. R4 is this one up. You guys, it's off screen. R4 is this one up here, and it's part of the positive 15 volt connection to this sort of mixing of all the signals, this current-based signal mixing line. There's a 1M on it that goes to a 10K trim pot to ground, and then there's a 200K that goes up to positive 15. So on the circuit that I have, 150 to 20 to positive voltage, and then all the way over here, 2M to 100 to ground. It totally changes up all the values. I mean, maybe if you calculate it out, it works out. What is this one doing? 470 with a 10 nanofarad to ground. And then this circuit doesn't do that. Nope, there it is. 470, 10 nanofarad to ground. So the question is, I mean, we've got 100K, 100K, 300, 3M3. Should I replace these values, the trim pot and R4, and then R4 I can have at 300? But it looks like having those resistors to positive means that you might be able to trim it better. But then it's not 100K, it's 220. That's a 150 and a 120. And then here you have 200 and 100. The difference between the 072 and the 074 is the number of op amps in the chip. $120, $150, $2M, $100K, and this thing swings towards the low frequencies more, is maybe what was the intention of the changes of values, is to make it favor those lower frequencies, because it's got less range of the lower frequencies. The lower frequencies just can be shown. That's so weird. We're having trouble with this thing because it's not adjusting. Things aren't like moving around. Now this seems to have been meant for 12 volts, so my theories are probably not correct about why we're having so much trouble. I may try it with a control voltage and see what that does, just because maybe that'll bring it into tuning a little bit more. But like this guy, this fellow has a really good write-up about the whole thing. So let's go to the next one and just see, because these are all crazy pants. So R18 to 18K, 20K, or 21. R18, which one is that? R19, 24, 26, 25. R10, 18, it's probably going to be one of these down here. 14, 15, 16, 17, we're in the right spot. We've run out of circuit. R18, where have you gone? Oh, that's this. PWM control, 100K input. Do we have anything like that? Well, this is related to pin 5 activity, although that's input, but pin 5, that's the wrong window. Pin 5, and I only can guess 3, 4, 5, PWM control. Oh God, what a mess. 100K PWM input, and then V plus 56K. R18 would be the pull-up 47K, but we're not going into an amplifier. We're going into what looks like a voltage divider. I don't know. Actually, we're going into this part, 100 picofarad and the 470K. We're not having trouble with PWM control, though. If necessary, change R7, resistor in series with wiper of octaves control potentiometer from 300 to 150 to get more range from the octaves control. 300, wait, which one is this? The R7. Because that looks kind of familiar. R4, R7 is the octaves. Frequency octaves control, RV1, 100K in. We don't have that here. It's like you flip it to ground or you can flip it to there. Yeah, we don't have that. We don't quite have that control on our board. We have log FM, coarse, fine, 1 volt per octave in and out. It's very similar. It's just some of the numbers have been fudged a little bit. R11 from 1M5 to 1M2. This will help with tuning, and if your problem's getting the VCO to track right for the octaves. Well, that sounds like our problem. We've got a 2M2 there. So what if we go down a little bit from this? Because it seems like our 100 kilo ohm tuning doesn't do anything. It's not tuning it. I think one of the first things we need to do is go through this and make sure that all of our pots are causing this line here to be at 0 volts. This mixing of all of the different signals. So yeah, let's hook up the probe again. Actually, what I could do is, so as long as we plug in one of these to the output, we'll want that anyway to look at the frequency, I could then use the scope clip. Here, we have this thing running that. That's fine. No, hold on. Let me think about this a little bit. I guess I can do shared ground through this by plugging... Actually, leave that probe on. I need this ground over here on the sensitive multimeter. And now the red probe will be my grounded probe, and I can look at the center pin of all of these pots. Actually, I should be looking at the value at pin 15, which I can just do this. And then, okay, let's get power into this thing. It's just strange that we're having so much trouble with these adjustments, because nothing is adjusting. It's just kind of sticking. Oh, I didn't turn the power supply on. Boop. All right, there's our wave. See, and what I'm talking about here is that there's an incredible range on this oscillator. I can go all the way down. But the problem is, like, that's not very functional. That's like a volt per day. And then I can go way up with not a whole lot of movement. And maybe I guess it's okay. But I can keep going up and up and up. And you can see right here, the amplitude starts to drop off as we get to the higher frequencies. Now, I'm not even nearly at the end of this travel. I have this much to go. So the frequency amplitude will drop off as it gets higher. But I guess its response to control voltages is really what we're trying to get here. And our control voltage is at 0. But I need to make sure that my knobs are all not affecting this channel. So I do that. And I get -6 volts. That appears to do nothing. Why are you sitting at -6? Is this a current thing? Huh. Why would that be sticking at -6? That's supposed to be 0. Or I guess maybe the center of the potentiometer is supposed to be at 0. 4 volts. Yeah, I guess I got to take all these to 0. It's a current thing. It's not really a voltage thing. Oh man, this is tough. This one's tough to get to nothing. This is a very sensitive multimeter. I need like a screw adjustment attachment for this. All right, I don't think I can move it any closer than that. So let's go to the next potentiometer and make sure that that one's zeroed out. This would be the fine adjustment one, although it does seem to have a lot of control. 4, 3, 2, 1. Now we're in millivolts. Get it just to where the sign changes. I'm like holding my breath. What I really need is something that'll clamp onto the pot and have just this really long arm that I can adjust it with. Okay, and then this one is supposedly the logarithmic adjustment, but it doesn't seem to do anything. Oh, look at that. It's 20, 19, 20, 12, 7. Weird. Well, there's no voltage on the legs. What's going on there? That could be our first problem, that we need to find out where this potentiometer connects. Because it's supposed to. Initial phase, fine adjustment, coarse adjustment, and then log FM right here. It's supposed to be a 100 kilo ohm pot, and it's supposed to be connected with a 100 kilo ohm resistor. So it should have the same effect that all the others do on that circuit, but it's not doing anything. I'm not getting it to do anything. Oh, I guess the input from logarithmic FM. Oh, maybe that's what it is. So that log FM connects to an external positive voltage when you put in a control signal. I don't have a control signal in there. Okay, that makes more sense. But it is a logarithmic pot. All right, so that makes sense why that's doing that. So right now we have this thing at 0 volts, on as close to 0 volts as we can get both of the potentiometers. So that means that our frequency, what is C4? 1 volt per octave, 0 volt. 261.63 hertz. So now we get it to 261.63 hertz, and I could do that by throwing the Hertz into my sensitive multimeter. Frequency, plug that thing in, 406.8. It said 200 briefly, it was just a harmonic, but that would have been nice. 407, that's unacceptable. Now we adjust it. Now, is it going to be that one, or is it going to be this? It's going up, going down. Looks like we do have enough control to get this to 261. No, we don't. That's 288.6. Oh, here we go. This is the one that's going to help me with that. I guess this is the fine adjustment, and the other one's the... might have something to do with scale, but... so 261... 5, 4, 3, 2. Being real careful, it's a 25 turn pot. It only hurts when I tune. Ugh. Need to recover from that. 261.63. Oh, that was so close. Oops, I went to 54. 26163. Damn it, keeps slipping. $50. 5. Okay. We stop jumping around so much. Why don't you stabilize for a second? All right, stabilize to 277. I'm going to pull it down from there. Let you stabilize, 270. I changed the trigger on this so that it actually works. There we go. 68. Got a little ways to go. 65, 64. Let it stabilize. Go just a little clockwise. 261.5. And the difference between this and the 261.6 is be the screwdriver equivalent of tapping it with a plastic hammer. What you're supposed to use, excuse me, I'm like burping while I talk. I don't know if I have any more of these, but what you're supposed to be using on these trim pots, especially the surface mount ones that are really finicky. Okay, can we finish burping? Nope, there was one more. What you're supposed to be using is a plastic screwdriver, because the metal screwdriver can influence the potentiometer. It's crazy. I think until I get the good capacitor, I can't exactly do this, but I can't believe that other article writer had the audacity of saying that this one was his favorite to tune. Yeah, see, it's walking up in frequencies as the board heats up. You can see all the heat down there, and it should be temperature compensated, but I don't know how long. I don't know how long it'll take for that to drift. This is as close as I can get. It should be a C note, and we would listen to it with our skull speaker if I had one, but I don't. I don't have it. I get all those boards, all those PCBs today, so I'll be able to just build the skull speaker in the background and put that all together. There probably is a speaker amplifier on this setup too. This is the light bulb socket speaker. I gotta go to like Micro Center and look at the grab bag stuff. Actually, wait, we do have these. I'm sitting here complaining about not having a speaker when I have speakers sitting right in front of me. How dumb. Got these stupid ones from Amazon. Problem is, all the cables are permanently attached to them. Which I guess isn't a problem around here. I can just fix that, but we'll use these for now. We'll have a cool speaker later. A cool TED Talk. Now, this is going to be a lot of volts for this thing, but oh. Why did everybody stop? No, wait, it didn't stop. I just need an adapter. And then we need it to be in the left channel. That's cute. I'm gonna get the attenuator over here, my passive attenuator, because that needs a little bit of help. Let's see, passive attenuator that requires hex for me to get it out of the rack. So I'll just grab this. It's like way over here. This stuff kind of walked around. Hold on, let's get you and just put you on the pile. Throw it on the pile. So we need to attenuate the output from the rack because the signals are so much hotter than a typical speaker input. And you could, I don't know if you guys could hear it, but I could hear it. It was distorting pretty heavily. So this is just a passive attenuator and mixer. And we'll just use one of the channels. Master mix. The monster mix. It was a scareful tricks. Not a lot rhymes with mix. It was a scareful fix. The monster mix. This is sounding like a completely different frequency at this point. Oh god, just touching it changes the tone. That's fun. That's the capacitor that's responsible for making the frequencies. So this thing is a pretty sensitive thing. How can I also send it to... This isn't like a splitter, though. I'd like to also send it to the scope, but I don't know how I can do that. I can do multiple patches. Here, let's first off, shut the hell up. Second of all, these will go on top of the scope. And then this needs to go to there. The setup is evolving Okay, so that turns it into stereo there. This mixes all of the outputs, but what we want is something in between these two locations so that we can measure everything. So what I can do, this is lowering me down to a one-channel oscilloscope, but I can take the BNCs and I can start mixing and matching things. They're becoming fractal BNC connectors. Today on No Bother. So we've got now an in and an out, and an observation, and a sensitive multimeter. It's getting a little crazy. But that just means that this is our patch through. There, now I can listen in while everything else is happening. Although maybe splitting it from here would have been a better idea. Because these are naturally splittable. But I need the stereo connector, so I don't really want to hear it all the time. But this has gone to 262. It's drifting around. So the next thing that I need to be able to do is inject my own voltage into this system over here. Although, you know, there's a tuning process that they want you to do, and maybe I could follow that process. Now that we know that it's working all right, it actually is working okay. It's the relationship between the fine adjustment and the coarse adjustment, and then we need to make sure that it hits the right notes in range. So that's going to be the next thing that we have to adjust. Let's see, what were we following that was telling us what to do? Yeah, there's a couple pages there. But I think this page had a tuning in it. And it seems like all of the mods here have been done by nonlinear circuits, so. Goes for all the project on this website. Measure every component before you solder it in place. It can save you an enormous amount of work of troubleshooting. We generally don't do that, but I mean, I guess it makes sense. That would be a sensible thing to do. Outputs are 0 to 10 peak to peak, not the 5 volt. Running the VCO 12. Yeah, this is a good build log. It's good to go along with somebody else's build and sort of learn what problems they had along the way. CD out. You can see the picture that I have CD out jacks on the VCOs. Synchronization and multiple VCOs. Okay, so what we need to do is find that guide that we were following, and I don't remember where it went. There's somewhere in here. Oh, we actually did, we had seen this page before. Wait a minute. I got multiples of these things open. Open up the gain potentiometer on your VCA so you get continuous voltage controlled amplifier. Key C5. See, this is doing it with a keyboard. VCO warm up for 15 minutes after turning it on. Yeah, that's kind of where we are. It's still heating up. We're at 262.13. It keeps sneaking up in frequency. VCO has 3 trim pots for tuning. Oh, there we go. But we're only going to use 2. Because the high frequency tracking or linearity potentiometer is not really effective for the lower octaves. That's true. So we leave that in the middle position. Is that in the middle position? Yeah, it is actually. Try to. Yeah, it's right in the middle position. So this is their specially developed method that that takes them less than 15 minutes to tune. If you don't have a useful tuner for calibration purposes, but you do have a smartphone, then I recommend you download the Universal Tuner app. Well, we're going to use the voltage equivalents of the various things. So the voltage equivalents, I guess I need to like. Wish there was like a calculator. Voltage, yeah. Let's see, 1V octave voltages Come on. Go on, Mod Wiggler. You can do it. I want like a table of values so that as this person's telling me to hit C4, C5, etc., I'll be able to, like, instead of tuning it, I'll be able to take it to the voltages. Oh, this isn't very helpful. I need like a table. There needs to be like a little applet where I can choose the volt. Not found. The problem with going through forums is that it's all so old that sometimes things are just gone. They're just gone. 1V per octave voltage table. Pitch and sense. Huh? That's more like it. Oh, it's the same website. Wait a minute, where's the table? Where's the table? Where did you put the table? Where is the table? And by request, here's a list of individual notes and their corresponding voltages. Well, there you go. The exact same thing that I was complaining about. So, yeah, 1V per octave. Expo output and frequency. So at 0 volts, or 0.883. All right, and then we go, I'm going to close that because we've already got it open. And our tuning procedure is here. Press the key C5, turn trim pot A until note C5 is in tune with your tuner. Trim pot A and trim pot B are probably the big and the little ones. Hold on, I'm not gonna lose place. Let's go back to where we were in this whole procedure. And then let's find the schematic of their circuit. Trim pot A is the multi-turn, and trim on positive, and trim pot C is the one that goes to negative. Trim pot B, what is B? Trim pot B, RV4. I think there might have not been anything wrong with this circuit then. Trim pot A. Trim pot B goes from pin 1. So that makes it... Oh yeah, I need to actually like look at that. So going from pin 1 over here, that's the multi-turn. Wait a minute, trim pot B is this multi-turn one? It goes over to a 5.6K and then it's got a 24 kilo ohm. It might not be that one. There's preset over here, and then there's scale over here. That's weird. Why did it turn off when I touch it like that, and then when I touch it now, it doesn't? Okay, hold on. The scale is the one that goes to pin 7. Pin 1 is trim pot B. And supposedly that's a 10K, although I don't think it is in this circuit. So that goes to positive voltage, that one goes to negative voltage, and then this one is the one with the 24 and the 5.6. So this is the multi-turn pot. This is the big multi-turn. Pot B. Site B. Key C5. I need this over here. My power supply that I can set very precisely. And then I need plus 6 volts. If I have to go above 6 volts, I'm going to be in trouble. C1, C2, D, E, C4. Hit. He gives us a table. It doesn't even go to C5. Are you freaking kidding me? C3 would be, well, it's 1 volt per octave, right? So expo outpoint 1 volt per octave volt, 4.0833. C4, B3 is, wait, why is B the even voltage? 0.833? That seems a little wrong. All right, well, anyway, let's put 0.833 into it. So we're looking at CV. Plug that in. Right now I'm at 0 volts and nothing changed over here. So what I need to do is I need to take my power supply, and it's the first thing he told me to do is go to, yeah, he can go to C5. And so C5 is going to be 5.0833. You can see the frequency's changing. 3, 4, 5.0, 5, 6, 7, 8, 3. 5.083. And the frequency we get is 9.4 kilohertz. I don't know what that's equivalent to. This table does not go high enough. What the dude, this guy is like, he gives his whole tuning procedure, and then he's like, you guys asked for it, here's a table, and it stops right before it gets to the frequency that he's requesting. C5 frequency, you freaks. C5. 523 hertz? Is that correct? I mean, this is like, we're getting up to 1108. That's not what we're looking at. Hey, thank you, Carthoris227. You're enjoying the stream? I'm getting stressed out. This is okay, though. Things are working. So, hey, I appreciate the well words, my friend. This is obnoxious. It doesn't go up to C5. Dude. You go to C5 and then verify that you're at we're at 9 kilohertz, by the way. So, yeah, something feels a little wrong here, right? But when we look up C5 frequencies, A4 at 440, it says 523 hertz. And this frequency is here. What's up, Blue? C5 frequency. Piano keys frequencies. C5. A, B, C, D. D, G, C, small octave, C3, C4 is home key, C sharp, C blah blah blah. This isn't helping me. D, B, contra octave. Oh, we're going down. This is where we need to go up. C4. Mark. I don't even know what that means. This is not very clear. This one seems a little clear. Frequency 1. What? This is not clear at all. I mean, I could probably get a tuning app on the phone. I don't really want to do that. I want to do it by voltages. C5, 523. We're at 9 kilohertz right now. One column over on the wiki. Oh well, I missed it. This is easier. 523. Table its pitches with their ISO note names, frequencies in hertz. That seems a little. MIDI note numbers, frequencies are the standard ones with 8440, blah, 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 equal temperament. Interval of 1 semitone, a frequency ratio of 2 to the 1 to 12th. Jesus Christ. Frequency equals 440 times 2 to the M69 over 12. M minus 69 over 12. What? That seems okay. So something seems wrong here because we're at 9 kilohertz right now, and we've got it on C5 voltage, like very precisely 5.078, and our frequency is absolutely enormous. So I want to verify with this guy's numbers because this guy has his own table, and his own table says that C4 is 1046 hertz, so 1 kilohertz. We're at 9, but we need to be somewhere a little bit above 1 kilohertz. But when I look outside of this guy's numbers, I'm getting much different results. Octave 5, 523.25 hertz. What then? That doesn't make, like, okay, I'm confused. It's like a big middle finger to everybody who requested the table to have his tuning table cut off early. It'll usually be the case when we start tuning the notes too far apart rather than too close together. And if you repeat the steps above, keep switching between C2 and C5 using the trimmer, A for the initial note and B for the low note. You'll notice, as mentioned before, that the notes get closer together and you'll have to turn trim pots less and less to hit the right note. Eventually, you'll be spot on. The VCO will be in tune over at least 4 octaves. Be careful that you don't overshoot. Notice that soon enough, if you have to turn the trim pots more and more to hit the right C note, in that case, use trim pot A for the low note and B for the high note. You can, of course, use even higher octaves and other notes. Tune it between A2 and A7, for instance. Leave that up to you. I don't use C1 for tuning because it's so low, my phone with the app has trouble tuning it. So I guess I could use C1. You get the hang of this tuning process soon enough, it's really simple. It just goes back and forth between the voltages. So if we use some of his, like basically we'll just use the min and max that he has on this table, and then we'll be able to tune it in his method. So the min and max, we have C0, which is 0.833, and then C4, which is 2.8. And the higher frequency is C5 that it's not quite stable on should be fine. So if I go between 4.0, and of course this power supply changes the numbers on you when it does change. So if I take this to, what were his lowers and upper? Oh wait, I'm just a mouth sitting here on the edge of the screen. Okay, anyway, C4 is 4. Oh, that's sharp 4. We'll do the regular one. 4.0833. 078. There's probably a different mode that I can get this into that'll stabilize that. So at this frequency, according to what's adjusted here, I should be seeing 1046. We're off by that by about 9 orders of magnitude, but you know, not orders of magnitude, by about 9 times. So now I trim pot A. From trim pot A to trim pot B. Which one was A? We have the numbers, we know what we're doing. I just need to figure out which one is which. This one is B. This one is A. A is the one that hangs off of that. So that's going to be this one here. So A and B, and then C is the high frequency one. Okay. So at the higher frequency, I don't know which one I'm supposed to be adjusting, but let's get this down to 1046. I can't. It's getting higher frequency. So it looks like it's like a push-pull between these two. I hope this doesn't start clicking. I can't adjust it anymore. Huh. So if I take the control voltage down now, two, 1, 0, that should be 65.4. We're at 168. Something is making us way too high frequency. Because, yeah, I can't lower that anymore. Uh, 65. Yeah, this won't let me go any lower. Okay, so what would be causing that? This is called the Linear Circuits 3340 VCO. And this chip is, what we're doing is kind of weird. This nonlinear circuits doesn't give you much information about what you're doing, right? They don't give you a ton of information. They don't have to. They don't give you a ton of information about what you're building. You put it together, and then many different people have made circuits with this ASIC. And there are only so many ways that you can use this ASIC. There are only so many specific ways that you can use this ASIC. And so what we're dealing with is a tutorial that's made for a different setup. Only slightly. The variations are very small, but the values of all the components are a little bit small. So what we're trying to do is tune it. So we take it from a known reaction to a voltage to another known reaction to a voltage. So I zeroed out these potentiometers, but it seems like it's not letting me. So let's double check here. I'll double check what's going on. Make sure I do everything correctly. Not blame the hardware first. VCO has 3 trim pots for tuning, but we're only going to use 2 because the high frequency tracking or linearity pot meter is not effective for the lower octaves. So we leave that in the middle position. I suggest seeing if the 1 volt per octave function works in relative sense. That's what I'm doing. That's what I'm doing. I mean, I could go 1 volt by 1 volt, but we're supposed to go from end to end. But it is, I mean, it functions. I changed the voltage. You guys saw when I was lowering the voltage, the waves were spreading out. So I'm trying to get like a baseline here. So let's see. Leave the middle position. Not effective for the lower frequencies, so we leave that in the middle position. This is the high frequency tracking or linearity pot. Now that one is in the middle position. What happens when I move it? Nothing really happens when I move it back and forth. Yeah, there's no change in the frequency. I just think that maybe the nonlinear circuits design is a little bit restrictive, or the adjustments aren't effective enough. It seems like the frequencies are kind of, I don't know, the spread is bad or something like that. I don't know. Turn the coarse tuner octave potentiometer off with the switch on the panel. Set the fine-tuned potentiometer in the middle tune position. We don't have the switch on the panel, so we need coarse and fine to be at 0 volts, which I think we were, but we needed to give it a little bit of time to heat up, basically warm up. Of course, when I have this in the Euro rack, I have holes on the front panel to get to all of these adjustments, just in case. if installing the potentiometers on the top means that things are skewed in the wrong direction. Like if I put the pots on the bottom, do you think it would affect it? 170 millivolts. What is this crap? I gotta be real careful adjusting this to get it to 0. Do I really have to do this every single time? I guess it shouldn't need tuning very often. I think I need to remove the power supply's effect and get that to 0. Yeah, that's as close as I can get. That's pretty close to 0, though. That's pretty close as well. Well, that ran away immediately. Two, 1, and then down. 40 is close enough. 0.04. That one doesn't have any effect because nothing's plugged into it. These all adjust other stuff. So those are set at a baseline. So now the frequency at this baseline I'm getting 120 hertz. But it should be 65 when I'm putting the voltage in. And if I plug in the power supply, I twitched a little bit, but it didn't change. And 127 is off the scale. I don't know what that one does. What does that switch do? Hold on, let me look for the front panel somewhere around here. That does edge. Oh, that's just the sync. Yeah, so log FM, linear FM, saw, pulse, PWM, pan pulse, triangle, sine. We're doing sine wave here. Oh, the triangle might be a little bit easier to... Yeah, I can't dial it back anymore. Everything is minimized. All my adjustments have been minimized as much as possible, and it seems like it's not adjusting anymore. Because if we put in 1 volt, we're going to get like 250 hertz. There's 1.088, and we're getting, oh, we're actually getting 230. Maybe we can get that tuned in. Okay, just touching the potentiometer was enough to send this all over the place. Maybe the scope was reading badly on the lower frequency. Now, like 250 hertz is not exactly right. We need to go to... Where do we need to go to? We need to go to note. We're 1.0833. This says 130 hertz is what we should be getting for our 1 volt. 130.81 for our 1 volt. Yeah, not quite. And I can't get it to go below 250. Well, very far below 250. Absolute frequency doesn't matter. It's the relative to the baseline, which you set to 127. What do you mean? I mean, we are adding the... We tried to minimize these guys to set them to 0, right? And so Although the control voltage, I guess, goes positive and negative, but 1 volt per octave. I'll have to redo that. I mean, yeah, I can get it to go way down. In spite of that, because that overrides. It doesn't override it. I guess you're saying it adds to it, which makes sense. But we were very careful to set these things to be. See, I guess he has the ability on his to turn the coarse tune parameter off with the switch on the panel. And actually, what is the switch on the panel doing? The switch on the panel in their schematic is actually turning it to ground, which I think is what we're adjusting between on ours. See, he has a switch there that just grounds the output. But it's also on a 300 kilo ohm resistor there. The fine adjust is on 3 meg. For our circuit, we has 20K and 150K. And for our coarse adjustment, it's 100, 100. But it's between positive and negative voltage. So what I did is I took the multimeter, and I got to do it again. I got to measure where 0 volts is. I know I can't. That's a dumb thing to do. DC volts. And take that down to 0 again. That'll be the equivalent of grounding it. Possibly not as accurate, but. So there. I've essentially taken that thing out of the equation by setting it to be exactly 0 volts. And I did that with the other ones too. So now that there's 0 volts, the only thing that Todd's barking at the door. The only thing that's affecting this is the adjustments and the CV volt, the CVs that I'm putting in there. So I'm wondering if I need to alter the 20K and the 150 kilo ohm. Because I'm not getting the adjustments that I believe that I should. And they have 200 and 100K. That would give you less of an effect on that line. But I guess you could do a larger voltage to plus 15. No, because you're 100 and 200. You're offset by 200 kilo ohms. So you're half the weight of everything else here. And you've got a 100 kilo ohm adjustment down. So essentially, our circuit, the one we have, we should be more effective at it because we've got a 150 kilo ohm. We are weighted 1.5 times. Sorry, we are rated half less, quarter less, because it's 15 instead of 30. Anyway, we've got less resistance weighting us more equally to the 100 kilo ohms. You see, the 4M7 is a fine tune. That way, this has very little effect on what's going on there. We zeroed out both of these, though, so we've taken them both out of the equation, and now we have less resistance available to us to adjust this to the 15 volts, but I can't get this low enough, the frequency to be low enough. Why is that happening? Could it be the 2M2 and the 100 kilo ohm down here? So the 2M2 and the 100 kilo ohm down there in the other circuit are $10K and 1M. If we replace the 1M, but that's linearity. I don't know if that really is gonna, I mean, that affects how weighted it is towards ground. Make it more or less linear at a lower frequency. I don't think that's, it's just, yeah. Getting the right notes on a table isn't as important as getting the 1 volt per octave right. You use the VCO, you use the knobs to get your baseline note. You put in different CVs, you get the relative notes. Well, yeah, that's what we're testing. We're doing it over a big range. But I can't seem to get the lower notes as easily as they would tell me I can get, which is weird because this thing goes very low frequency. It's just my adjustment is no longer effective at those low frequencies. But what we're doing is we're flipping it from voltage to voltage in order to use the trim pots to fit the numbers in, right? That's why, and the reason that I'm using numbers for frequency and not tuning is just because my equipment is hooked up to it in that way. This multimeter is way more accurate than something that is listening in on the speakers. But yeah, what I'm trying to do is establish that. And if I do it over one measurement in the middle, if there's something else wrong, I'm highly suspicious of what this guy's table. It cut off before the frequency that he wants you to adjust it to. So it does seem to be a little bit sus. It's just the only example I have of the 3340 doing exactly what it should. Now there's this 1 volt, 5 volt, C1 to C6. And I guess I could adjust that. 5 volts is C6. Do they give me a frequency? C6. 1 volt per octave, e.g. to produce middle C 261. The control voltage would be 3 volts. Each octave is divided into 11 intervals, 1 voltage per blah, blah, blah. So if I do, and they don't give me a frequency on this either. This is about the 3340 though, so. Used in a circuit with 2 trimmers that must be iteratively tuned several times in order to achieve the C1 to C6 music scale. This is the schematic. The internal op amp A2 that drives blah blah blah. What is C6 though? They're not giving me. There we go. 1046.5. So let's take it up to 5 volts and get it to. Yeah, I don't know why that guy's table said 0.8 on it. Let's just get it as close to the even voltage as possible. And I'll do 5 volts. And then that should give us, with the pots zeroed out. Yeah, I think you're right. I think you're totally right about that. A bit of a sus. At 4 kilohertz. And it should be 1046. This one's from Thonk. Oh, that's just the data sheet. You guys need to let me cook. I can't even, like, that's the 1 page of the data sheet? Yeah, that doesn't help. Okay. 1046.5. We're at 4.6. Oh my god. Can I get it down to 1040? I mean, what I'm trying to say is that the frequency does matter because for some reason I have to adjust this very greatly, and I have to bottom out both of the adjustments in order to get it to get close. There's the click of the multi-turn pot. And so I can take this, see that raises it, take that all the way down. So now I've bottomed out both of them and I'm way too high frequency. Something is wrong. That's what I've been trying to say. Yeah, this doesn't do anything. These shouldn't affect it. It's weird because my trim pot is the right value, so it seems like something else might be a bad value. That is a 100 kilo ohm pot. That one is a 20K. It goes to a 150K with a star. So with less or more would give us more ability to bring it up positively and raise the frequency, right? Okay, so there's two adjustments in here. Where am I showing you guys this? Well, as per the old data sheet too, it's frequency control inputs right here, and they're all weighted based on the resistors that they have. This one calls for 360K, huh? So we have 2M2 going to a 100 kilo ohm pot, and then we have a 20K going to a 150 kilo ohm onto this line. The two adjustments are fine and coarse, and I've taken both of those to 0 volts, so right in the middle. The alternative way of doing it is to use something like a ground and switch the pot over to the ground. That's what this person did in the article we're reading. Ours doesn't have that. So I just get a multimeter and I set these to be as close to the middle as I can possibly get them, using the voltage readout. So then they're weighted 100 kilo ohms and 4M7, 4 million, 4 mega ohms. And we've set them to be as close to nothing. So they are off, right? And then we inject a voltage in the 1 volt per octave, which is weighted evenly as the 100 kilo ohm. And then that goes onto this line and induces a current that we are trying to get to represent the kilohertz frequency, but our adjustments aren't able to go low enough. I'm wondering if it's the 2M2 or the 150 kilo ohm. Now, one of them biases it to positive and the other one biases it to negative. It feels like maybe we need a little bit more negative bias in this. Although one is actually linearity and the other one is scale, so I don't know. If our line is such that it's, you know, we can't produce the frequencies. So maybe we put a 1M in there and we see what happens. Let's put a 1 mega ohm resistor in there. Yeah, they're these two, the 20K here and the 100K here. This one does the high frequency adjust, and we saw that it does nothing when I flip it back and forth. But these two are bottomed out on one end. If I plug in the multimeter, I guess we could see what the relationship of them is to the rest of the circuit, and then we'll have a little bit more information about where we should adjust. So it would be from pins, well, actually from the positive voltage to this multi-line here. So from positive power, where are we going to get that from? I think that's this up here. Power input comes in, goes through the caps, and then we don't have much of a sense of where it goes. Oh, positive voltage is just on the last pin here. So the plus adjustment, oh, that's megahertz, ohms. Although, then again, it would be working in parallel with the other ones, too. So this doesn't really give us this isn't a great sense of what's going on. 43K, and then between here and negative would be here. No? Here? No, it's 68. Which one is that? That's this one. 50 ohms. But the problem with that is that there's a bunch of resistors in parallel there. So I think that's basically what I'm measuring. I'm not really measuring the potentiometers. We've got, like, you know, half of the pot on one end, half of the pot on the other, the 470 through a capacitor to ground. It's a mess. We're going to put a 1M in there and see what that does. See if we can't get it to adjust a little bit more evenly. I mean, the 150K also had a star next to it, so I don't know if that's what's going down here. But yeah, it just seems like the adjustment is all the way skewed towards one end, and I don't know why. 0603 resistors, get that book here. This thing's taken a lot longer to tame than I thought it would. So it's either that one or the 2M2. That one's 1M2. We have a 2M2 on here. 4M7, 1M2. There's the 4M7. So this would be the No, wait, that's not the right one. That's the one that's after the one input. And the one that I'm looking for is, there you are, 2M2. There's a star by it. There's a star by both of these values. 150 and 2M2, huh? Well, let's put a 1M in there and just see what it does. We'll do this by feeling around and bumping into the bumpers. That's why we play bumper pool. We're not old enough for regular pool. Our brains are too smooth. These are 04? Yeah, okay. Neat little ASIC, but there's a much simpler VCO that I want to build that uses a different chip that I have. And it can do 20 to 200. Where did that go? Oh, it's still in here. That 100K does not look very soldered. Although we did go over the solder. We know everything's pretty much in here. And it seems like the more we get into it, the better it's responding to us. I think my initial impression of it being skewed over to one side is probably correct. Speakers are in the way of the soldering iron button. Oh my god, this is a mess. I got too much stuff all over the place on this desk. You know, I bet somewhere in like linear circuits, nonlinear circuits notes or whatever, there's probably a, oh, the iron is completely off. There's probably like a note about changing these values in order to get the proper adjustment. We don't have access to anything like that. M2. Goodbye, 2M2. And welcome, 105. Huh, I guess these are 0805s. I thought they were 0603s. I'll have to go grab the 0805s in a minute. Let's get this soldered in and just see what happens. Come on. I think that's got it. Oh, damn it. It's heating through the resistor, so it's getting to both pads. At least that helps me center it a little bit. We'll just leave it a little janky in there. We'll leave the janky one in. Let me just get this out of the way. Said. All right. I'll have to see if there are any notes on the schematic itself. Or no, there are no notes on the schematic, but in the bill of materials is where all the notes are. Okay, all right, put that away. Come back over here. And then I gotta hook everything up to test again. That's off. And then actually, I'm gonna need the multimeter first. Just double check that our things are at 0. So they're not influencing like an influencer. And then patch through one that's hanging down. Not plugged in. What just fell on the floor? What was that? There's stuff, like as I'm moving things around, like everything is moving on the desk. Because I've been so keen on getting these things to work that I haven't been cleaning in between sessions here. Actually, we don't need the negative lead for this. And then DC volts. That's still very low. That one went up to 40 millivolts. Ooh, the adjustment is like 1 atom to either side. All right, that's as good as it's going to get. And then our output frequency. .3 still. What is the How much does this adjust? It goes up, 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 up. Look at that. I can go up to 4 kilohertz. Up, up, up. Let's see if this one goes down any. This one just goes up. I don't get it. I don't get it. We put a smaller value in there and it didn't really change. Either be a smaller resistor here to ground, and it's sensing the current in here for output. So do larger or smaller values. Let me see if there's any notes on the like the 150, 1M2, 2M2. There's no notes on it, even though there's a star next to it on the circuit board. Huh. Actually, there might be notes on the blog about this. Let's try build. So this is what we were looking at before. VCO NLC, nonlinear circuits. Okay, now that's a new thing to add. Build notes. Featured 4 waveforms, extremely unusual in that it offers both hard and soft sync options. Featured in many famous synths. What problems did you have? Tell me. 3 trim pots, 10K, 10 turn, Tadya A, 20K single turn. I only have the 20K on hand, so I use some non-Tadya pots for the rest. EK100 linear pots. What the rear looks like. All right, now tell me about how you tuned it. Nothing. God damn it. They don't say anything about tuning. You built it. This is a terrible mistake of a build log. Click here to return the NLC build index. That's all you have on the 3340? This guy's built a lot of stuff. Hey, brain custard. So there's barely any information in the build notes. It's almost like everybody got it to work perfectly, huh? Yeah, I've read their trimming thing, but look, nothing. We're in trouble here. Nothing is going to work because we can't trim it down far enough, right? Bug? What bug? Is there a bug? Every time I say bug like that, my dog freaks out. Is there a bug? He goes nuts. Like, just having trouble with this. Hold on, I want a larger version of. I guess we can't zoom in. 24K. And then down here, 2M2 with a star. That one's 150 with a star. I have a feeling I need to put different resistors in this in order to give me more adjustment. But I'm trying to figure out whether I want larger or smaller components. I feel like probably smaller components. But we put half of the value in and it didn't really do much. So the PCB and the panel, this was like, if they put more notes on tuning it, the best DIY build. Control F, nonlinear. We checked out the nonlinear circuits. That's it. That's all we get. See one YouTube video of it. Can't seem to find more information on them working. Yeah. VCO Euro rack, PCB and panel. What is this? That's a different build. It's a different thing. VCO schematics and PCB DIY. schematics. Ugh, not easy to follow. Oh God, I hate this Reddit wrapper. Or no, this isn't. It's a Google Drive wrapper. It's like, yeah, I wanna look at this closer. Let me use the scroll wheel. Reset. No, I need to go further in there. Open with a connected app. I would like to view. I don't want to download this. All right, fine. We're gonna have to put on our reading glasses here. I can't even see the value of that. That's 100K, I think. I think they're following the data sheet on this. So that's 2M2, and that one is 20K. That one is 100K. Did I get my 20K and my 100K mixed up? Could that be it? Could that be why nothing is adjusting properly? I have 20 on the upper and 104 on the lower. I think that might be it. Hold on, let me double check. No, this one shows 20 on the upper. Maybe they got it mixed up, and that's why I'm so confused. Let's check this circuit. 10K on the lower, 100K on the upper, and then is there 20K on the other one? I think that maybe they got them mixed up as well. And that's why our adjustments are so janky. Well, this is 10K, 10K, 100K. If I put a 10K in that upper one, I don't know if that's really going to help it, but maybe it will. We'll try it. We'll swap these and see what happens. See if suddenly this thing makes a whole lot more sense. No, this is labeled as 20K, and this is labeled as 100. Never mind. Never mind. As usual. Well, oh yeah, that's right. What if they flipped them? Right. But the high frequency in the other data sheet is shown as a 10K. If I make the 20K a 10K, I don't know if that really helps me. I can't adjust down far enough, which is why I thought a lower, maybe a larger resistor on the negative would be able to bump up the voltage a bit more. But that's the linearity pot. That seems a little... I'm thinking of, like, I can't get this to bias low enough. And so that has a 1M, as do we now. And if adding I don't think adding resistance helps me adjust more. I would think making it bias to ground more would help me adjust it down more, but that apparently isn't the case. I am so confused. What does the 1M2 do? Oh, I guess that's one of the inputs. Ah, Lord. I'm not getting any of this. I don't understand. Wish this would let me zoom in a little bit more. But yeah, I guess that doesn't quite do it. And then in the suggestion in the actual data sheet, they say to use... Well, they don't have adjustments on these, huh? 470.1, 1M into a 20K pot. And then they don't have an upper adjustment. They have just a 360 kilo ohm. Well, 360, maybe that's what's going on. We don't have that upper value because we have 150 and a 10K. So if I made it 360 kilo ohms and followed one of these other circuits, okay, that's what we'll do. Okay, so we're going to replace a couple values here. Because yeah, 150 and 200, and then 2M and 100K. They have 20K. Or did they bias it based on separate stuff? Hold on. No, they're still using 100Ks there. Yeah, it looks like we should just take the values from the other components and put them in there. So I need a 200 and 100, and then I need a 1M, and then a 10K, although they have the original data sheet says 20, Twentington on the high frequency track, which is what, no, we have a 10K on the high frequency, 104. We'll keep that 10K because it'll be a little bit more minimal surgery. So we did the 1M, so all we need to do is the 360 ohm, and we'll follow this circuit, which is 200 and 100K trim pot. So that means that I need to get this 20K out of here and replace it with 100. Because, yeah, it's supposed to equal to 360. This one would equal to 360 when you max it out. Huh. All right, so let's get basically both of these out of here. Getting the trim pot out is going to be kind of annoying. These are weird to move around, but you do it by sneaking from bit to bit. Yeah, it's funny because there's like no information on tuning, specifically tuning the nonlinear circuits version of this. And nonlinear circuits plays it kind of fast with the rules. All right, I've got the screwdriver in there, and that's giving me a little bit of pressure on this. Now I just need to jump from pin to pin and apply mucho heat to get this thing to pop out. Because it's through hole, everything is trying to remove the skin from my hand in whatever creative method it can. Oh, okay. All right, now I got to get the front foot. I think the actual sanctioned way to do this is to just clip the leads off. Come on, buddy. Come on. There we go. I don't want to rip off the pads. The problem when you put pressure on it like that, it's stressing out the pads on the bottom layer when it's just about to come out. You got to be careful that you don't rip up a pad. These pads seem to be pretty well established, though. They're pretty decent. Need like tweezers to grab it. There we go. All right, so that is out. Yes, indeed. I don't see how raising the values of these two would give me the adjustment parameters in lower frequencies. But maybe it will. Maybe it will. This seems a little suspect to me. What's up, Ilya? Visual asthma. Desoldering stream. The capillary effect. And you. Ow! Shouldn't have done that. That was very hot. That was very toasty. Hot heat. Where's all the solder? It's saturated. Ah, the whole braid is hot. There it goes. Oh no! One of the ones that holds on to stuff. Maybe we still have a hope. Oh yeah, there we go. Perfect. Okay, so now we get the 150 out of there. Huh, it would be interesting if that wasn't really actually soldered and that was the whole problem that we had, because that didn't look very well soldered. But then again, yeah, the 150 just heats through very quickly. The 0805s, I guess, carry a lot of heat with them. So we're going to put a 200 in there and a 100 for the potentiometer. I bought a kit of potentiometers, so luckily I don't have just only the part that I need. I have a group of parts that can allow us to adjust this stuff. So 100 kilo ohms, huh? That's what it's going to take. 104. And then a resistor. Resistor! It's going to be 200 kilo ohms. So I need to find... My 0805s are in the big bins, so I need to find which big bin has 200. Those are mega ohms. Oh my god, this is like the least organized the shop has been in a while. Wait, I'm out of bins. What the... Hold on a minute. What are the other... Start feeling around. I'm feeling the bottom of the drawer. Hold on. All right, let's see here. Oh, I see. And this wire wrap thing got in the way, or a perf board thing. Ohms. Mega ohms. 20K, still too small. These are capacitors. $200K. Let's get that one out. We'll see what this does. All right, now if I'm good enough and the 0805 can transmit the heat well enough, I can drop the tweezers on the floor and then get mad. All right, those tweezers. Okay, let's get this right. The trade-off would be the granularity, right? If you... I mean, maybe I need to like run numbers on the circuit to figure out exactly how it's working. I know it's described in the data sheet, but just so I know the effect that all this stuff has. Burning snowman, burning cookie. There's a couple fire emotes, huh? I'm hot like burning flame. It rhymes like fire. Ah! Okay, so, I mean, it's in, but it's sloppy. Oh, come on. Beautiful. I'll make sure that that's soldered all right. Oh, it's a Welsh cake? Cookie that's cooked on a griddle instead of an oven. Huh. That sounds good. I want sweets, but I don't want the consequences. I want to make cookies. We don't have the stand mixer on the kitchen counter, and it affects our ability to spontaneously make cookies. I would be so incredibly fat if that stand mixer was in the right spot. Okay, so we're going with known good values, not the nonlinear circuits values, in part because the nonlinear circuits doesn't have any tutorials anywhere about how to tune that thing. So like, what are these values you're using? Maybe they're what he likes, but it hasn't been able to do anything here. Yeah, bread, pasta, pastries. Exactly. You do pizza dough. All you need is a ton of flour. And you just get your dough hook and go to town. All right, let's get the speaker. These speakers are just in the way. I'm leaving the speakers behind. We're not listening to shit. All these things do right now is just produce notes. We don't need those. We don't need that. We don't need nothing. We don't need nobody. So I'm undoing that. And our tree of plugginess is going to get broken down. This stuff can just go over here. I want my skull speaker, damn it. And all the parts for it are arriving. So. And this we don't need anymore. This crazy clown pipe. Monday, I get the oscilloscope. Excited about that. I spent my own money to get it. I did not get a sponsor or anything. I don't know how we'll take it through its paces, though. It'll probably be more accurate than my multimeter. Okay. Output, check. Power, check. Input of 5 volts. That changed. That frequency went way lower. It says I'm at 39 hertz. That might have been it. Now that we're at a lower voltage, if we're at 5 volts, that's almost on the money. That's what the hell? So the changes that I did were on the, where is it? Pull up is now 100K. And then right after the pull up, the biasing is at 200K, which will 100K and 200K, so it's about 300 kilo ohms, which is close to the 360 that it originally called for in the datasheet. Instead of 2M2, I have 1 mega ohm in there and still a 100K linearity. So now we can take it between the frequencies, the extremes, and get it right. And I don't know, these numbers are kind of sussy-bussy. So we can use different numbers for C1 to C6. So what were we aiming for? So C1 to C6. 10K resistors or blah 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 blah. I mean, their tuning method is fine. You just jump between the two. But the voltage levels we got from here are much cleaner. C1 and C6 are 0 and 5 volts. And so we're going to 1046.5. And then C is, I think that's earlier in the documentation. So let's just try this. So if I go to 1046, and 11. This is very hard to control. Yeah, and it's rising because that capacitor is getting heated. So when the precision caps get in, I'll have a better time of this. Oops, too far. Whoa. 1046. I just want to put digital caps in here and have it tune itself. Yeah, see, it needs a long time to heat up. I don't know, we could just still try it, and then C0 or whatever, 0 volts. C0 is, well, C1 is, yeah, 0 volts is C1. What's the voltage we're expecting there? 0 volts, C1, 261. No, 3 volts would get us middle C, which is 261 hertz. I gotta look it up. Oh, here we go. No, wait. Note, A4, A note above middle C is 440 hertz. Oh, this is wrong. I keep clicking the wrong scenes because I change stuff around. I'll get used to it eventually. 0 to 5 volts. So 0, which one is 0 volts? What's the frequency of C1? Is C1 frequency. We already had this open in a window. I could probably get it from one of the other windows. Not that one. Or could it be? I must have closed it. It's not. C1 frequency, they're saying it's 32.703. A4 is 440. Yeah, they're right. 32? Well, let's see what this goes down to. So it's 4.997. This is what I hate about this power supply. It said, oh, I dropped off a millivolt. So here, look, I dropped off a millivolt. But now when I adjust it, I have 999 on there. There. $41.6. That's getting close. Actually, Google was probably right then. C1 is 32.7. So I can take this down, and I can use either adjustment to do it, but I need to get a balance between these. 32.7. Three. 32.7. Come on. Oh, 32.5. I need to go up a little bit. I feel like these should all be multi-turn trim pots. The only thing I'm competing with that capacitor that's heating up. When the good ones get in the mail, I'll be able to do this a little bit better. But okay, so now we go back to 5 volts. And we're at 650 hertz. We should be at, what was it, 10 something or other? Hold on, C6 frequency. 1046.5. So 1043. That's close. Let's go back down to 0 volts. We're at 52, and we need to be at 32. Wrong direction. Oh, that's a lot of adjustment. This is a weird kind of push-pull that we're doing here. Because we're trying to get the linearity and the scale to match up. It'd be better if we had a sweep visualization to do this with. 30. When I touch the pot, it affects 31, 32. Go back to 5 volts. 644. Take that up. To 1046. This one seems to be kind of a pain to adjust, huh? That digital VCOs don't put up this much of a fight. $30, $30, $45. Oh, 46. This is like changing variables in a control system. All that feedback and weirdness causes it to have all kinds of weird effects. Nothing is linear. Technically, this should be linear. That's getting closer. So that has to be 32.7. Three, 32.8. We'll go back to 5 volts. And that needs to be 1046. $1046.5 is really the 104.65. I don't know if I can actually get it that accurately though. I can get it really, really close. Not exactly. And so now let's go to 0 volts again. 36.7. We're supposed to be 32. Getting real close. $36.8 I'll take. And then we go back to 5 volts. 1049. So I can continue to noodle around with this until it's totally accurate, but this is actually pretty good. And with a tuner, I'll be able to get it closer, I guess, if I get an app. But that's how you do it. So you zero out, which is going to be difficult to do when this thing is in the panel. You zero out these two potentiometers, and then that allows you to tune it. So then you'd give it 0 and 5 volts and get it to the frequencies by adjusting the linearity at the top and the scale at the bottom. So you take it down, scale it properly, then you check to see if it's linear, adjust the linearity, et cetera, et cetera. You go back and forth until the numbers get close. So, hey, what's up, Copper? So the problem that I was having in not being able to adjust it properly is that the values for the components did not match what the datasheet had. With the datasheet values in there, I'm burping so much. With the datasheet values in there, I was able to actually get it to properly adjust, and then I can follow an adjustment procedure. Not enough caffeine. Still waiting on shipment. Doing good. It's been quiet. It's a quiet Saturday. This month, November and December, people are very busy, so we're not getting a ton of viewers. I am no XQC. I do not get that many people watching me. It would be nice if they would, but I understand that content is not for everybody. I'm getting a bunch of cool parts today. I am getting parts for the skull speaker so that we can actually make a good attempt at this skull speaker and make it actually do something, because it was cool and then it doesn't work and now it's not cool. I want this to be able to be the thing that's sitting here on the desk making the frequency noises. And then I'm also going to be getting that new wire stripper that I want to try out. It's a kind that has like a thin front, and it clamps down and auto pressures itself, and then when you pull the handle, it pulls back. So it's like this like pincer thing. It's like an alien jaw, like an eel jaw. So yeah, I think the 3340 VCO works. I'm still waiting on a part, so I can't actually get it in to the rack, which is really unfortunate. That was supposed to be the triumphant VCO tune that finally got this thing to work. But this is cool. I mean, this is a pretty easy circuit to build. It's just took a little bit of difficulty figuring out exactly how to get this thing to work. But now I guess supposedly it works. And now I've got voltage per octave on a variety of different signals here. I got the PWM that I can control. I don't know what any of this stuff does. I'll learn what this thing does. Oh, I see. It's the upper and the lower of the PWM. Nice, nice, nice. That doesn't do anything there. What do all these things do? It's like I'm gonna have to like write the numbers down on this thing in order to get it to tune right. So we have control voltage inputs, we have a soft sync and a regular old hard sync, a linear FM, log FM, so that's control voltages to control logarithmic or linear, and we can sync on the edge. We have PWM input. I don't know if that syncs it or is that the output? PWM there. No, yeah, that's an input. PWM output, sunk by that thing. We have a saw wave, sine wave, triangle pay, and then pan pulse. Whoa. What does that one do? Nothing. So that one's the input to pan pulse, and the pan PWM is kind of weird. This one is the pan PWM control. It doesn't do anything. I guess that's per the input, and this one pans it back and forth. That spike is a little unnerving. Whoa, that just looks cool. Oh, I see. That's the width of it. Oh my god. That would be a cool control signal to use on something. Like your own VCO. And you could turn the frequency way down. Uh-oh. This needs to be 1020 something or other. 1046 or other. Oh, but I don't know if it's measuring properly on there. I touched the knob and detuned the whole thing. You're revealing new guitar pedal effects. What's wrong with that? What's wrong with that? I do need to do guitar pedal effects. Actually, not. I need to do the effects that the synth is gonna have. It basically, I have a Bic and Tick filter that I haven't done anything with in a while, and then I have a oh man, this is really hard to adjust. I use the fine tune. See, with those other two tuned, now I can tune this, and it should just put it into the right, you know, scale and everything. There we go. Wait, is it 1020? No, I'm thinking of the wrong numbers. It's 1046. This thing is a little jumpy. It would be better to have like a, you know, like a tuning app on the phone. And then I guess what I can do is I can plug the sine wave into this. Well, I put the speakers away, move the speakers away. But I mean, we could just look at how something like a VCO or just a control voltage we could look at and see how it affects things. So I'll plug this in. And then I can just take the random of voltage, I can put it into the CV input. I can turn the power supply to 0 volts. Well, I just unplug that and then put that into the CV. I've got different waveforms coming in. And I can plug this thing into a speaker. Not with this, though. I want to view the waveforms while they're rolling in. God damn. Why is that one stuck? All right, fine. Nobody sees anything anymore. It's getting a ground loop now. That's why it's reading 60 hertz. And this thing, I don't have any effects to put on it, but plug it in here. What am I missing? Attenuated, speakered, and then this goes in. Oh, yeah, that's right. And the other cable goes in here. Wow, it sounds like the future. I got my dog to start barking. Turn that down a little bit. Yeah, so that's a little bit, with something that can wibble the voltages around, it can give you something interesting. Kind of wanted to bias lower voltages, but I don't know how that's accomplished with marbles. Wibbling. Yeah, so that's kind of cool. I don't know. Sounds crazy. But that's what a VCO does, where marbles is using the timing ticks here in order to drive random voltages, and I can set how spot on they are or how they drift into one another. And with our 1 volt per octave tuned, that could be scales of octaves. If I take this thing all the way into... There's the classical computer is thinking sound. Oh wait, it's in the wrong speaker. Ah! Fucking 60 hertz piece of shit. Ah! The computer is thinking. Yeah. Beep borp, it is me, a robot. I am the new tone. Oh, that's fun. Yeah, pretty cool. You can do all kinds of weird shit with this. I could even feed it back into itself and do weird stuff, like take the weird PWM and put it into any one of the controls, I guess. I have no idea what that's doing to it. Play the Star Trek theme song. Weird, but it's getting to be more of a modular synthesizer. What we need on top of this is effects. So that's finally done. The CEN 3340 VCO is done, and it's doing stuff Marbles is done and it's doing stuff. I have Brain Custard. No idea if that works. It kind of doesn't. I think I need to lower the frequency significantly of Brain Custard. Oh. That doesn't affect this. Oh, that's like a catch-up. Better to give it a little bit of that. So we still have Crimes and Punishments. We have the Bic and Tick. We have the VCA, the voltage controlled amplifier, which I think is done. It's just I haven't had the time to tune and test it to figure out how this thing is going to work. It's basically you have a control voltage input, you have an audio input, and then the output will be sums of all of these mixed, but control the mixing you can control with a control voltage. So that'll be another thing that can get wibbled around and make cool noises with all their stuff. Right now, it's always outputting from that. So hopefully I'll be able to explain it to you guys a little bit too, because that's one thing that I think is lacking, is the ability of the people who I have had on stream with the modular synthesizer stuff, explaining exactly what they're doing and why they're doing what they think they should be doing, where and why and how. But tuning this thing, wow, so annoying. I almost want to do a touch panel on this, because it does kind of a cool little like blah, blah, blah. Higher frequencies. Oh, yeah, that's the wrong one. I don't know. Seems fun though. I'll have to get to know this stuff a little better. I don't even know what the center knob does on this thing. I see, so that's the repeatability. Go to the other end and be like, bleh. Cool. All right. Well, that's the first major component of VCO. It's nice to actually have. I'm sure you guys can barely hear it, and I don't think you want to really be hearing what it's doing. It's just going and hitting just like weird random notes. Yeah, I think I'm gonna stop on a high note for once, because I'm waiting on parts for everything else. We started a little bit early, but this thing is getting really annoying. Okay, I gotta turn it off. Ugh, that's better. No, the CEM3340 is an ASIC, an application-specific integrated circuit, and with ASICs, there's very specific ways that you use it. Especially something like this is very specific. You sort of choose what ins and outs you'd like to have, and I followed nonlinear circuits. Nonlinear circuits is a fellow who, it's achieved sentience. It's going to fight me by giving me ground loops. What am I saying? An ASIC, typically, the application, in order for you to need an ASIC, is so specific that you basically open up the data sheet and do exactly what's in the data sheet. That's what a lot of these people do. They do exactly what's in the data sheet. They add a couple little whistles and bells, and that's it, right? So what nonlinear circuits does is he designs like a new module every month. The guy is a busy guy. He does a lot of incredible stuff. I like how he builds these things because they are completely disorganized, like a big bird's nest. And the components are larger sized and they're more standardized. And so that makes it much easier to build. The problem we had, and this was not written anywhere because that's what I signed up for, I decided to buy the PCB. They give you no information about any other facet of the build. You got to figure it out. So that pushes us to learn more. That pushes us to learn deeply what's going on in the circuit itself. I've had to run equations to get some of these things working properly. The problem that we have, not something that I think a lot of people would necessarily experience. We had 2 values, maybe 3 of the components that were not the datasheet values. So that on this circuit, And again, this documentation boils my blood. This just gives me a full body cringe, because they didn't number the pins, even though you're assumed, I guess, that they're on the proper sides and everything. They forget dots in some places. Like, as somebody who worked for 10 years making schematics that were meant to be viewed by people who weren't necessarily electrical engineers, I have some notes. The Erica synth stocks they're good. They're not amazing. A lot of stuff has been pulled out of the designs that are useful, like your initial testing. We had a huge amount of problems with marbles doing the initial testing, because the STM32 on this board doesn't have just like a serial printout. And so without that serial printout, I had to look at the code and figure out exactly what it was doing and see whether or not I could get it to tell me what it should do. What I ended up doing was the equations on the amplifiers, figuring out what their sitting voltage is and how exactly they work, which again is what I signed up for. That pushes me to learn deeper how these different functions, how the different circuits are interacting with one another. It's basically forcing me to learn how this stuff works, and it's working. Look at all those different frequencies running around. I wonder what it sounds like. It sounds like I'm drowning. I'm gonna end up recreating modem noises. Those are just the different modes of the trigger, but the trigger influences. The Erica synths are very well documented, though. I won't short sell you on that one. Ah! Oh my god, I've managed to make it sound awful. I barely know what I'm adjusting here. 8-bit video game. There was a module that does chiptune sounds, and I was thinking about whether or not I wanted to do that. I don't know if I necessarily want chiptune sounds running around. You got to draw a line in the sand somewhere, right? All right. So anyway, this was a success. We actually got a couple modules working. I guess moving along, I'd like to get the VCA working too. This one I might do in the background because it's not going to be as cool. Maybe it will be cool. Maybe it will be cool. Yeah, this one I very quickly designed just a bracket to hold it out like that, and then my own front panel that was very very compact. Computer thinking sound effects. That's what it's doing. Let's ask the computer. Uh-oh. Well, now it's just Morse code. Ooh, we almost had something there. We've almost got a bass line. Neat. It's like a cursed C64 song. Very strange. So that locks it. Oh yeah, that changes the voltage level. Ah! Oh! Ah! Okay, all right, all right, all right. That's getting a little crazy. It's just like fluttering all over the place. Ah! Whoa. This is madness. This is just madness. Well, that's cool. That's a lot of fun. All right. Turn all this crap off. Get out of here. All right. I think I'm done for the day. It's a little early, but, you know, we've had kind of a time getting stuff working this week. At least we end on a positive note. I got something working for once, and it made cool wibbling sound noise things. It needs a little bit more. It needs a filter, and so I have a voltage-controlled amplifier. I have, I think, maybe 2 other filters. I don't have a lot. What is that one? BMC something or other, and then a couple more mutable instruments modules that we need to get into working shape, which it'll be a struggle, but I feel like I'm probably going to want more filters, and I'm probably going to have to look for filters that I can put in on this thing in order to make cool sounds, but I'm hoping that I can at least somewhat simulate a drum at some point. Yeah, the thing I like about their documentation is that teach you how each part of it works. I guess that the manuals do, but my experience with mutables is that there wasn't a thing that teaches you exactly how everything works. You had to kind of go in and figure it out in order to troubleshoot what was wrong. But you know, the code is there. It's uncommented. You can go through the microcontroller code and figure it out. It all depends on which module you buy. There's greater and less documentation on the spread of different modules that are out there. So anyway, I am going to breakfast. It's 1 p.m. over there, or 12. You've inverted your schedules. Yeah, I'm out of here. I don't know where I want to point you guys. I don't know who's doing what. Let me just open up my own page because I'm that vain. Cosmo Quest is doing some stuff, but I will Queen Ella and then Ghost Freak, and then it's all the popular people. Yeah, it's a quiet Saturday, so I'm going to leave you guys to what you need to do, and you guys can reroute yourselves to wherever you go on the internet. And YouTube, you do whatever. I don't know what you guys do. In Twitch, where you can raid other channels and bring all my viewers over. I don't think YouTube has that yet. I don't know. Anyway, have a good one, everybody. I'm going to go take my doggy for a walk, and then we will come back on Tuesday. And on Tuesday, I don't know what we'll do. If I haven't already, you know, fallen to temptation and built the computer speaker, we'll do something else. We'll do something else interesting. Until then, I will catch you later. Have a good one. Goodbye. Where's the scene that I'm going to? I should do that promptly after saying goodbye and not dawdle like I am, because then I'll end up just sort of doddering here and talking about absolutely nothing in a kind of a circular fashion, in that I will just keep saying things at about the same word rate, but they're actually just sort of describing one singular thing that I'm doing, that I'm sort of vaguely just talking about.